Hello, and welcome to Intermediate Algebra, Unit 3, Lesson 2, Calculating Slope. Throughout this unit, we'll be investigating lines, and slope is a very important characteristic of a line. We'll use this information that we learn here over and over again throughout our math career. So here are our lesson objectives. We need to calculate the slope of a line from a graph, calculate the slope of a line if we have 2 points, calculate the slope of a horizontal line. Now, a horizontal line is one that goes along the direction the horizon would go, side to side, or know that a vertical line has an undefined slope. A vertical line goes straight up and down, like a wall is vertical and a floor is horizontal. So you could remember it that way, or if you're still struggling with remember that, we need to come up with a way for you to remember that. So what is slope? Slope describes the direction of the line as you look left to right in the graph and the pitch of it, the steepness of it. It can be positive, negative, 0, or not definable. So a line that goes like that has a positive slope. A line that goes like that also has a positive slope, but it's steeper. And the steepness is important and the direction is important. So here's a picture of a graph with a positive slope. You can see it goes up in this general direction. Now, how do we find the actual value of the slope? So the direction is positive, the steepness is a number. We will get to that in a few minutes. So, and here's a graph with a negative slope. We think of moving from left to right. So if you're looking from left to right here, a graph with a negative slope looks like it runs downhill. A graph with a positive slope looks like you're going uphill, if you imagine yourself walking on the graph from left to right. This is a graph with 0 slope. This is a horizontal line. Right there, horizontal line. The height does not change. A mountain has a slope because you're going uphill, the height changes. If you have 0 slope, then the height does not change. You have a horizontal, you have a flat surface. And this vertical line has what we call undefined slope. If you can't walk on it, the slope is undefined. I don't know, that's something that helped me remember it, whether it helps you. So straight up and down like that, vertically, is a undefined slope. Now, you could say, oh, that's a straight line. Well, actually, all lines are straight. This happens to be a vertical line. That's what makes it undefined. So, let's calculate the slope of the line shown on this graph. Slope is essentially, in words, we think of slope as rise divided by run. It is a ratio. That ratio sometimes comes out to be an integer, and sometimes it's a fraction. But it is a ratio. So for my graph here, I pick a point and I pick another point that's easy to define. And I move from the first point to the second point by going vertically and then horizontally. The vertical distance is called the rise. The horizontal distance is called the run. So I have to figure out how far did I rise. Well, I started at y is negative 2, and I stopped at y is 0. So if I want to know this distance here, it's top minus bottom. The top is 0. The bottom is negative 2. When I subtract a negative, it's like adding. That's why we always do top minus bottom, because I guess this makes sense that it's positive in this case. So the rise is 2. And the run also looks like it's going to be 2, because now for the run, for dimensions this way, the run is right, in this case, right minus left. And that's how we calculate the run. So 2 minus 0. So the run is also 2. So the run, sorry, I'm having a little trouble, technical difficulties here. The run equals 2. So I had a rise was 2 in the last slide. If you rewind the video, you'll see where that came from. So goes up 2 and then to the right 2. Up is positive, right is positive. And if you have the ratio of 2 positive numbers, you get a slope of 1. And so the slope here is rise over 1, run. And we abbreviate slope with an M. So that's from a graph. Now, often we're not giving our line in the form of a graph, but maybe we have 2 points and we need to calculate the slope. The rise was the change in height. Rise was a change in a vertical dimension. That comes from y-coordinates. So we want to know the change in the y-coordinates. And it doesn't matter which point you call point 1 and which one you call point 2. You just have to do both the rise and the run using the points in the same order. So here is the formula, but it really comes down to rise over run. The rise is going to be y2 minus y1, and the run is going to be x2 minus x1. I calculate the rise first, and the reason I do this is the big difficulty students often have with this is they tend to join the upside down slope club. Not on purpose, but by mistake. So if you write the change in y, write the rise out first, and then below it write the run, so 9 will be the rise, -4 will be the run, then you're more likely to make the fraction in the right order with the right thing on the top. So the rise is on the top, the run is on the bottom. Now, let's have a word about fractions here, because this is always a point of struggle in many students in a class. So if I have 9 over -4, that is the same value as -9 divided by 4. And remember, fraction symbol is just the division sign, but it's also the same as the negative of 9 divided by 4. Because 9 divided by 4 itself would be positive, so now you have a negative. If you did a positive 9 divided by a -4, you would get a negative result. Or a -9 divided by a positive 4, you would get a negative result. It does not matter whether you put the negative sign there or there. What we tend to do is put it out in front of the slope once we've calculated slope. So again, here's another one. Let's calculate the slope between these 2 points. There are my 2 points. This is x1, y1, x2, y2. You may be noticing that y1 and y2 are the same, and that affects our result. And it will affect, if y1 and y2 are the same, our result is the same every time. So I calculate y2 minus y1. When you subtract the number from itself, it doesn't matter whether the number is positive or negative, you get 0. So there's your rise, is 0. And your run is -4, and that turns out not to even really matter, because 0 divided by any non-zero value is 0. So the slope of this is 0, and these points make a horizontal line. Let me show you that. If I draw a little grid, and I want to plot the point 3, -5, and I want to plot the point -1, -5. Well, 3 would be over here somewhere for the x-coordinate, and -5 is 1, 2, 3, 4, 5 down here. So 3, -5 would be about there. -1, -5 would be about there. And what you see is you get a horizontal line. Now, if you did that on graph paper, it would be clearer that it was a horizontal